Hello everyone, good day to all of you. We are back with another lesson and you are watching Insights. Today we are going to be talking about decimal numbers. Now look at this number 782.124. Now the decimal point here denoted by a little dot marks the end of the whole number part. 782 is the whole number part, and the numbers that follow it to the right form the fractional part. A number immediately to the decimal point, this 1 represents 1 over 10, and this 2 represents 1 over 100, and this 4 represents 1 over 1000. So from 1 over 10 we have 1, from 1 over 100 we have 2, from 1 over 1000 we have 4. Note that 5 is actually 5.0, 6 is actually 6.0 because there are no fractional parts after either 5 or 6. 0.2 means 0.2. It is usual to write a 0 in front of the decimal point. Accordingly, 0.2 would be written as 0.2. Now let's discuss how we can perform the basic arithmetic operations: addition, subtraction, multiplication and division on decimal numbers. Now let's look at the addition first. 0.5 plus 0.67. Now in this case, it is very important to have the decimal point to represent the correct fractional part. In this case, 0.5 represents 1 over 10 and 0.6 represents 1 over 10. Therefore, the decimal point should be just in front of 0.5 and 0.67. Now let's add 7. 6 plus 5 is 11. We put 1. 0 plus 0 is 0. We can write 1 because we carried 1 from 11. Now there should be 2 decimal points after the whole number because 0.67 has 2 decimal points. Look at example number 2, 0.25 plus 0.6. Now 0.6 can be written as 0.60. Therefore you can directly say 5, 8, 0 plus 0 is 0, 0.85. Now let's look at subtraction. Now subtraction is same as addition. You need to put the decimal point in the correct place. 0.654 minus 0.321 is 4 minus 1 is 3, 5 minus 2 is 3, 6 minus 3 is 3. 0 minus 0 is 0, and we put the decimal point here because we have 3 decimal points on each of the numbers that we subtracted. Look at second example, 0.789 minus 0.62. Now here I can put 0 and then I can subtract. 8 minus 2 is 6, 7 minus 6 is 1, 0.169. Now let's move on to multiplication of decimal numbers. Now the easiest way to multiply a decimal number is, let's say I want to multiply 0.25 by 0.5. Just ignore the decimal in both the numbers for a moment and we multiply by 5. 5 into 5 is 25. We have 2. 5 plus 2 is 5 into 2 is 10. 10 plus that carry 2 is 12. Then we multiply by 0. 0 multiplied by 5 is 0. 0 multiplied by 2 is 0. 0 multiplied by 0 is 0. Then what we do is we add these two set of numbers, 5 to 1 and 0. We have 3 decimal points, 1, 2, 3. Therefore we put a decimal point in front of 1. So our answer is 0.125. Let's look at another example. 0.001 multiplied by 0.25. 1 into 5 is 5. 5 into 0 is 0. 5 into 0 is 0. 5 into 0 is 0. 2 into 1 is 2. 2 into 0 is 0. 2 into 0 is 0. 2 into 0 is 0. 0 into 1 is 0. 0 into 0 is 0. 0 into 0 is 0. 0 into 0 is 0. So you need to have these 3 lines representing the multiplication effect of each number, and then you write down the numbers. Then you count how many decimal points you have. 1, 2, 3, 4, 5. Therefore, you say 1, 2, 3, 4, 5. Move 5 decimal points and put your decimal sign there. So that is how you multiply decimal numbers. And now let's look at how we are going to divide decimal numbers. Okay, we are going to divide 0.52 by 0.2. Now the easiest way to do is multiply both the numbers by 100. 0.52 multiplied by 100 is 52. 0.2 multiplied by 100 is 20. Now what we can do is we can use the normal division and divide 52 by 20. So for 52 we have two 20s, we get 40. Then the remainder is 12. For 12 there are no 20s, hence we put the decimal sign and take a 0. So for 120 we have 6 20s, therefore our answer is 2.6. Now this answer is exactly same as the answer that you would have obtained had you didn't multiply both numbers by 100 and divided 0.52 by 0.2. But it's a strenuous process. Instead, you could use this easy method of multiplication and divide using the normal method and arriving at the answer. Let's look at another example. Now 0.369 is to be divided by 3. Therefore, I can directly divide this by 2 because all the numbers in the decimal sections are multiples of 3. Therefore, you can directly say 3 divided by 3 is 1, 6 divided by 3 is 2, 9 divided by 3 is 3. Answer is 0.123. Now we will discuss the scientific notation. Now it's often necessary to use very large numbers such as 6.5 billion or very small numbers. Each number can be expressed in the form of power to 10, that is a to the power n, where a is usually a number between 1 and 10. Now, if I expressed 6.5 billion in terms of scientific numbering system, I can say 6.5 into 10 to the power. I have to move 9 points from 6, therefore I can power 9. If I represent this decimal number in terms of scientific notation is 1 multiplied by, now in this case we have to move 10 points. But however, I need to put minus 10 because I'm going towards the number having zeros before the number. Therefore, in such a situations, we have to use the minus sign because 10 is 10 to the power 1, 100 is 10 to the power 2, 1000 is 10 to the power 3 and so on. Similarly, 10 to the power minus 1 is 1 over 10 or 0.1. 10 to the power minus 2 is 1 over 100 or 0.01. 10 to the power minus 3 is 1 over 1000 or 0.001 and so on. Now let's consider a few examples. Now 68,000. How are we going to represent 68,000 in scientific notations? Now this number does not involve any decimals, so therefore we can directly say 6.8 to the power. From 6 we have to move 1, 2, 3, 4 points. I could say 6.8 multiplied by 10 to the power 4. Look at this example, 0.09. Now in this case we have decimals. From the decimal point to get the whole number we need to move 2 points. Therefore we can say 9 into 10 to the power minus 2. Now we will work out few examples related to scientific notation. Now if we are to represent this number in scientific notation 0.000698, I can say 0.98 multiplied by 10 to the power. I have to move 1, 2, 3 and 4 points minus 4. Now how to represent 7.5789, which is already in the decimal form? 7.5789 multiplied by 10 to the power 4 positive 4. How to represent 750,000? 7,569. Now this can be represented as 6 decimal points. I have to move 1, 2, 3, 4, 5, 6 decimal points. Therefore I say 7.507,569 into 10 to the power 6 positive 6. So that's about scientific notations, and then we'll move on to significant figures. Now if you want to represent numbers in significant figures, let's say I consider this number 6.352. 0.28. I have to always look at one more digit than the number of significant figures and round up or down. Considering if the digit is greater than or equal to 5, then round up, else round down. Now 6.3528. The first significant point is I have to consider 6 and 3 because I'm going to write the number in first significant form. 3 is less than 5, therefore my answer is 6. Second significant form. Now if I am to write this answer in second significant form, I consider 3 numbers 6, 3 and 5. Since 5 is greater than or equal to 5, I can say 6.4. I increase 3 by 1, I would say 6.4. Now third significant point is I have to consider 4 numbers to write a given number in its third significant form. Now the fourth number is 2, therefore there is no addition and I can directly write 6.35. Look at these examples. Example number 1, 36.482 to third significant point. Now to write this number in its third significant form, I have to consider 4 numbers. Now the fourth number is 8, therefore I can say 36.482 in its third significant form is 36.5. Look at example number 2, 1.0049 to fourth significant point. Now to write a number to its fourth significant form, we have to consider 5 numbers 1, 2, 3, 4, 5. 9 is greater than 5, therefore I can say 1.005 is my number to its fourth significant form. Now I'm going to write 0.0473 to first significant form. Now to write this number in first significant form, the most important factor here is that we need to ignore the preceding zeros. So we consider 4 and 7 as our numbers. 7 is greater than 5, which is the second number, so we write 0.05. Okay, that's about significant figures, and now we'll move on to decimal places. Decimal places or rounding is where we express a number in a more concise form. 63.4261 2 decimal places. Now consider the number to 3 decimal places, that is 4, 2 and 6. If the final digit, if the third number is greater than or equal to 5, add 1 to the preceding number, therefore I can write 63.43. Now let's consider the difference between decimal places or rounding and significant figures. Okay, let's consider these 3 numbers and see what's the difference between rounding off and writing a number in its significant form. Now let's round the first number to 5 decimal places. Now I have to consider 6 points after the decimal sign. 1, 2, 3, 4, 5, 6. I get 1. 1 is less than 5. Therefore I can write 0.48573. Now when it comes to significant figures, I consider the 0 before 4. And I consider 6 numbers and I get the same answer, 0.48573. Now in this case, if I write the second number to 5 decimal places, I get my fifth number is 0. 0 is number 1, 0 is number 2, 2 is number 3, 4 is number 4, 6 is number 5, and 8 is number 6. So I consider 6 numbers and evaluate the 6th number, that is 8. Therefore I can add 1 and I say 0.00247. If I write it as a significant figure, I have to consider all the zeros. I'll consider only 2, 4, 6, 8 and 3. Therefore 1, 2, 3, 4, 5. There is no 6th number. Therefore I'll write it at 0.0024683. So that's the difference. Under significant points, we do not consider the zero. But when it comes to rounding off, we have to consider zeros after the decimal point. Now the last number rounded to 5 decimal places would be, we have 4 zeros in front, 2 and 4. 4 is less than 5, therefore if it was rounded it should be 0.00002. But however, if we write the same number in significant figures, I do not have the 6th number because I ignore all the zeros. So the number will be written as it is, 0.0002468. So that's about decimals, performing arithmetic operations on decimals, scientific notation, and rounding off and significant figures. Hope you enjoyed the video. Thank you for watching. Have a great day.